fast is something going after it accelerates? The answer to this question is actually dependent on several things. First, we need to know how quickly does the vehicle accelerate. We also need to know how long it accelerates for. And finally, we need to know how fast it was going before it began to accelerate. So let's answer this question. How fast is something going after it accelerates? Let's say that a car starts from rest and then accelerates 10 meters per second squared for a period of time. How fast is the car traveling after each second? Well, remember that saying something is accelerating at 10 meters per second squared means that its velocity is going to increase 10 meters per second every second. So at the beginning, the car is not moving, so its velocity, which is really how far is it going, is 0 meters per second. After 1 second, it will have accelerated to 10 meters per second. After 2 seconds, it will have accelerated to 20 meters per second, and so on and so on. So when we say that something is accelerating 10 meters per second squared, we mean that each second that goes by, that object is moving 10 meters per second faster. Let's look at another example. Let's say that a car starts from rest and then accelerates 20 meters per second squared for a period of time. How fast is the car traveling after each second? Well, again, since it says that the car is starting from rest, that means that the car isn't moving, so its velocity, or how fast it's going, is 0 meters per second initially. If it accelerates at 20 meters per second squared, after 1 second, it will have accelerated to 20 meters per second. After 2 seconds, it will have accelerated to 40 meters per second, and so on and so on. So when we say that a car accelerates 20 meters per second squared, that means that its velocity will increase 20 meters per second every second. So let's look at the last one. Let's say that a car is traveling at 5 meters per second, and then it accelerates 10 meters per second squared for a period of time. How fast will the car be traveling after each second? Well, this time the car isn't starting from rest. The car is starting at 5 meters per second. So at the beginning, the car is moving 5 meters per second. So as it accelerates each second, it's going to be going faster and faster than that 5 meters per second originally. So after 1 second, it will have accelerated to 10 meters per second more than the original 5 meters per second. So it'll be going 15 meters per second. After 2 seconds, it will have accelerated to 20 meters per second more than the original 5 meters per second. So it'll be going 25 meters per second, and so on and so on. So if we have a car that's already moving, and we want to find out what its new velocity will be after it accelerates, we're going to find out how much it accelerates and add it to the original velocity. So we're going to put this into an equation. We're going to call it our final velocity equation, and we use it whenever a question asks how fast is a car going after it accelerates. And our equation looks like this. VF equals VI plus AT. What we would do is we would take the acceleration and the time and multiply them together. And then we would add that value to the initial velocity. So we'll look at a sample problem. How fast is a minivan moving after 3 seconds if it accelerates at 4 meters per second squared from a velocity of 15 meters per second? So the first thing we're going to want to do is write down our equation. So V final, that means how fast our minivan is going at the end, equals V initial, that means how fast the car was going at the beginning, plus A times T, our acceleration times our time. We'll plug in our variables next. So VI, which is our initial velocity, is 15 meters per second. A is our acceleration, which is 4 meters per second squared. And it's accelerating for 3.0 seconds. Now we're going to plug those numbers into our equation. So V final equals, for V initial, we're going to plug in 15 meters per second. For our A, we'll plug in 4 meters per second squared. For our T, we'll plug in 3.0 seconds. So we're going to multiply our acceleration times our time. So V final will equal 15 meters per second plus 4 times 3 is going to give us 12. Meters per second squared times seconds is going to give us meters per second. Now we can add our two values together. So V final is going to equal 15 meters per second plus 12 meters per second, which is going to give us 27 meters per second as our final velocity. Again, when we do these kinds of problems, we want to show the same kinds of steps. We're going to write down the equation that goes along with the problem first, pick the variables out of the question and write them down, plug the numbers into the equation, do our math, round to the right number of significant digits, and make sure our answer has a unit. Again, if you're not quite sure what we just did, you can go back and listen to the video again.